Hello everybody, my name is wyattcieluch. Today I will be overviewing DSysTigs hardening on DigitalOcean droplets. Brief overview of the presentation today will include the scope of the project, the benefits of implementing an automation process like this for hardening your machines, a brief network diagram showing the setup, a Gantt chart breaking down the project and the stages it was broken down into, and as the script runs, I will go over the STIGs that are actually being used and protected against on our box. So for the scope of work, first it's to create the droplets in DigitalOcean, connecting to those droplets via SSH, and hardening those droplets using DSysTigs standards. For this purpose of this presentation, I'll be going over the Category 1 STIGs. However, the script includes hardening for Category 2 and 3 issues in the DSysTigs, so there's a lot more to the script than I'll have time to present today. And then lastly, documenting and presenting the results and processes is also an important part of the process. So the benefits of a project like this, first and foremost, is automation. Really frees up a lot of manpower and hours that would otherwise be used to do the tedious task of hardening machines individually and manually. Second is for security reasons, ensuring that you have one script that hardens all the droplets for you. You have no need to worry if you missed a step, if somebody didn't configure something properly. You kind of have this golden script that accounts for all of the security issues that you know of, and once that script is tested and validated, you can be sure that your security for each machine is as good as it can be. For compliance, it's also really nice because you have an easy way to show here's what we have done to protect the machines, the data on the machines, as well as to ensure that nobody is able to gain access to file systems that they shouldn't otherwise have. So for compliance reasons, having an automated script to perform these processes is very convenient and can often save you a lot of time again in making sure you are compliant with various regulations. And lastly is speed. Obviously, having a script do it for you instead of having to type in each command manually is going to save you a lot of time, and also it allows you to work on machines, work on more than one machine at a time. You can simply start the script on one machine and then move to the next machine as you need to implement the DSysTigs. So the objectives and mostly the benefits of this is speed, as we've talked on before, security, consistency, and efficiency. Here's a brief network diagram showing how this system is set up. First, a RESTful API call is made from the server, in this case our Ansible server, but it can really be any computer since we're working in the cloud. That call is made up to DigitalOcean to create the two droplets. Once the droplets are created, an SSH connection is initiated between the server and the droplets. Once that connection is made and the server is able to control the droplets that were created, it can then begin to harden the droplets using the DSysTigs that we have created. Here's a Gantt chart showing how the stages of the project work. Let's see if I can move this. Let's get that out of the way. So as you can see, it was broken down into 4 main parts: the research phase, the script creation phase, the script validation phase, and the project presentation phase. Each of these phases took about a week and involved a few main tasks. So in researching, I had to research the RESTful API calls to DigitalOcean, applying DSysTigs to droplets, as well as ensuring that the SSH connection between the server and the droplets was being made correctly. Week 2 involved mostly creating the script, that included selecting the stakes that I wanted to include, picking the cloud platform. In this case, this was a pretty easy pick, DigitalOcean. I created the Ansible virtual machine that will be deploying the script. Again, really any machine, and even these days, mobile devices can be used to deploy the script. And then in week 3, it involved a lot of validating, running the script in various environments, testing the stakes were properly implemented, and then making any tweaks to the script as needed. The final week was the project presentation. This included creating the project presentation you are viewing now, creating the project report that I will be submitting alongside this presentation, doing a final script validation, and we were supposed to have a outside security specialist maybe coming in to test our work. However, given the circumstances, that's not going to be possible, but that's still in the steps there. Alright, and before I overview the stakes here, I'm going to go ahead and start up the script, and then we can go back to talking about this. Okay, so we'll let that run, and we'll go over here the stakes that we're protecting against. So V723301, this is a high-risk vulnerability, and that is that the Red Hat Enterprise Linux operating system may not have the Trivial FTP server package installed if not required for operational support. Also, Red Hat Enterprise Linux systems prior to version 7.2 using UEFI must require authentication upon booting into single user and maintenance modes. Kind of skipping down here a little bit, V71989. The Red Hat Enterprise Linux operating system must enable SE Linux. And because without the verification of the security functions, they may not operate successfully, or the failure may go unnoticed. V71979. The Red Hat Enterprise Linux operating system must present the installation of software patches, service packs, device drivers, and operating system components of local packages without verification they have been digitally signed using a certificate that is issued by a certificate authority. So again, this is making sure that anytime you're getting software from outside of your local enterprise, you're ensuring that it is signed with the proper certificates to make sure that it is valid. Alright, V71993, the Red Hat Enterprise Linux operating system must be configured so that the x86 Control-Alt-Delete key sequence is disabled. This is to ensure a locally logged in user who presses Control-Alt-Delete when at the console cannot reboot the system and get into other administrative modes. Alrighty, let's see some other important ones here. V71969. The Red Hat Enterprise Linux operating system must not have the ypserv package installed. Removing this package decreases the risk of accidental activation of NIST services. And one last one here before we go and check in on the script. The Red Hat Enterprise Linux operating systems prior to version 7.2 with BIOS must require authentication upon booting into single user and maintenance modes. And this is, again, like UEFI. If the system does not require valid root authentication before it boots, anyone who invokes single user or maintenance mode is granted privileged access into the machine. So it's very important that you are ensuring that these maintenance and single user modes are still protected. Okay, as you can see here, those droplets were just created, so we have a little bit more time to talk about a few more of the STIGs that were implemented. The Red Hat Enterprise Linux operating system must not have the Trivial File System Protocol server installed, not required for operational support. And the Red Hat Enterprise Linux operating system must be configured so the file permissions, ownership, and group membership of systems files and commands match the vendor values. So all in all, ensuring that these STIGs are properly implemented is a key part to ensuring the security of the machines. Unfortunately, we are not really able to show a true test of the STIGs being implemented, kind of given our circumstances here today. Overall, though, it is an important step for anyone in IT to ensure their machines are properly hardened to protect against outside interference. And I will go ahead and leave you guys with the thought that ensuring that you are secure from the beginning is what ensures you do not have to pay out in legal fees and also, more importantly, a loss in customer trust if a breach does happen. So ensuring these STIGs are properly implemented is vital to ensuring you have proper trust between you and your customers. Thank you guys so much for watching. Sorry I went a little bit over time, and I hope you guys learned something. Thank you.